The submarine has the position vector given here and needs to set a course to an underwater cave located here. We want to determine the constant velocity that the submarine should travel if it is to reach the cave after 4.5 hours. So it actually has to travel negative 39, negative 68.5, negative 23.5, take away negative 3, negative 1, negative 10, giving us negative 36, negative 67.5, negative 13.5. It needs to do this in 4.5 hours, so divide by 4.5, and that gives us negative 8, negative 15, and negative 3 kilometers per hour. We're told in the question that this velocity is the submarine relative to the water, and we're given that the velocity of the water is 1, negative 1, 2. Now, SVW is equal to VS, take away VW, so the velocity of the submarine is SVW plus VW. So that gives us negative 8, negative 15, negative 3, plus 1, negative 1, 2, and that gives us negative 7, negative 16, negative 1. The position vector of the submarine relative to the cave is equal to the position vector of the submarine, so that's negative 3, negative 1, negative 10, plus t, negative 7, negative 16, negative 1, take away the position of the cave, which is negative 39, negative 68.5, negative 23.5, so that gives us 36 take 7t, 67.5 minus 16t, and 13.5 minus t. Now, since the cave is something that sits still, this is the relative velocity vector. The minimum distance occurs when the dot product of the relative position and the relative velocity is 0, and we can solve for that on the calculator. So action, advanced, solve, and then we want a dot product, so vector dot p, and our first vector, and we need square brackets for that, so it's going to be 36, take away 7x, 67.5 minus 16x, and 13.5 take away x, and then the other vector is the velocity vector, so negative 7, negative 16, negative 1. Okay, and this is the solution to equal 0, even though we didn't get around to putting the equal 0 in here. So 4.397. And remember, that's the solution to the dot of these being equal to 0. Since it's a 5-mark question, we probably ought to say that. So 36 minus 7t, 67.5 takes 16t, 13.5 minus t, dot negative 7, negative 16, negative 1 equals 0, gives rise to this answer. Then what we want is the modulus of this vector with t equal to 4.397. So that would be the square root of 36 take away 7 times 4.397 squared plus 67.5 take away 16 times 4.397 squared plus 13.5 take away 4.397 all squared. Calculating that gives us approximately 10.9 kilometers.